right. Welcome, everybody. Welcome to another episode of High Voltage Live. I'm your host, Willie Snyder with Nat King Code, coming to you live from the Mile High City, home of the Colorado Avalanche. And I'm joined by my colleague, James Stallcup, the inventor of High Voltage, Volt Online Academy and High Voltage Live. He's actually running the stream and everything for us. And he's joined with a special guest too. We got Senior in the house, so really stoked to have this episode going. Hey Felix, good to see you, brother. We have a great episode for you. I'm just so thankful of all the people that have joined up and participated in all our stuff. We got the death match going. We got all this stuff, and I think there's probably about a couple weeks left. Or maybe just a week left.
The end of this week, I'm going to do a post to remind everybody that got to the end of Sunday, and then I'll post up the May questions.
Okay, awesome. And I just a big shout out to the Rebs group, the residential electrical business. If you guys out there have any issues with your business stuff, they had to do a podcast on Wednesdays. I think it's like around 5:30 Eastern or 7:30 Eastern, 8 o'clock Eastern. You have to check on the group. And then the Fix It Queen, Amanda, she has a thing she does the 1st and the 15th. So if you have any business related stuff that you just want to try to help out your business and help it grow and stuff, check those guys out. There's a lot of really good information they have on there. And I really appreciate all the people participating in the Nat King Code this week for Myth of the Week. It is so awesome. I mean, we just every week just kill it. And so I appreciate you, James, for sponsoring my thing and helping me out. It's been really awesome. I mean, I always have apprentices come up to me and they're like, "Hey, what's the Myth of the Week, Willie?" And I'm like, "All right, And so everyone learns through this process. It's really awesome, and it just means a lot to me to have support from Volt Academy, and it's really awesome that I could support the death match and just throw stuff out there, advertise for people, and just just made me realize how much learning this really does for all the young guys out there. And a lot of these myths are people aren't going to believe them. And it's just been an awesome thing to be doing it, and then especially doing with the Code Ninjas. We had this idea to just do the 2023 Code Ninjas and start getting into the language for the 2023, and it's not 100% signed in, written in stone yet, but there's a lot of good things happening. Looks like with 2023, and so we want to try to throw some of those changes in there. And I really appreciate Felix. Felix is always crushing my Myth of the Week. He's always crushing my code questions in there. So it's pretty awesome to have somebody like Felix participate. Felix is coming to us from Colombia. So.
Oh, wow. Okay,
yeah.
Cool.
Yeah, we got Colombia in the house.
Oh, we got a really good one on the different groups. I did a little video presentation of 210.8F and what's taking place there, and I think people need to go over and take a look at that. It is there's a lot of information in that little presentation I did, and I give opinions and statements and also show the substantiation from co-making panel 2, and also I address TIA. I forget which one it is. And then at the end of it, I show all the NITNAM, the CADs that people, different ones that were submitted. And one of them was really funny. He said, "Just get rid of the whole section." I was like, I agree with you.
It's got some problems. I mean, it's the only place in 210.8. It's the only place in GFCI protection where they mention the outlet. Oh, we got Richard. Hey, what's up, Richard?
Hey, Richard.
That 210.8F it's kind of a problem one, because like you said, if they really wanted AC units to be covered as part of one of those protected devices, then they should have put it in D.
Yeah, as a matter of fact, if you look at what they wrote in D, they literally say this will cover all outlets, and then they They have it in F. I mean,
Yeah.
it's ridiculous. I mean, and I have every bit of that in that presentation. So everybody needs to go over to Vote Online Academy or NEC for any of our groups. I posted it in all of them so everybody could see and take from that what they want. But I give you word for word what they say, and I break it down. So I show you their first revision, what they said, the second revision, and then I correlate everything. And then I do the TIA and the NITNAMs and everything. And then you make a decision what you think.
Oh, we even got a LinkedIn user up in here. That's pretty cool. That's the first time I saw somebody come over from LinkedIn. That's cool.
Oh, that's awesome.
So yeah, so the myth of the week this week was really awesome. And a lot of the guys, you know, I'm not saying it looks like you got the old one up there, but
Oh, I forgot to check. Did I?
yeah,
Let me make sure.
yeah.
Nope, I just didn't change that first
yeah.
one.
So the last week's myth was the supportive
Yeah.
raceway 36 inches. But anyway, so this is one of the ones that you'll see a lot, and I'm not telling anybody to, you know, like go against what like their boss or their company is saying, because a lot of the residential guys, they say they only put two I'm going to say Romex, but it's actually NM cables, so non-metallic cables. I always say Romex just so people understand what I'm talking about. But Romex is a name brand. It's not an actual cable type.
Sure.
So basically what people like to say is no more than two NM cables per hole. And, you know, this is just basically showing that, you know, if you have a bored hole, you got to have your clearance, you know, your 1.25 inch clearance, or else you have to throw a nail plate up there.
Mm-hmm.
You know, nowhere in here really that I see, unless I'm missing something, James, does it say how many cables you're allowed to put in that hole?
There's not. And the only thing you'd worry about will be actually in the next one. And I put this here where they
Okay.
talk about bundling of cables.
Right.
And that's the only place you would really worry about this, where it's more than 24 inches, and that's for dissipation of heat and everything. But
Well, there is an actual reference, and it's uh did you put three, what is it? There's another reference to it in non-metallic in that code article. That's the 80 of that article that says for ampacity adjustment.
no,
Um
I didn't put that in there. I just,
yeah, and
uh,
so it's 34280, I believe.
it
But
is,
the 34280, if you guys have your code
or
books out.
348. But
33480. Yep. Thank you. I
yeah,
appreciate the correction. I like I say, I didn't have my code book handy. I just barely just rolled in from work. But so in 334.80, it basically says that if the holes are to be sealed with like a sealant or like an insulating material or some kind of thermal insulation, then you have to account for those current carrying conductors. And I think it says no more than 3 or 4 current carrying conductors if you're going to seal that hole. So that's where a lot of people say only two current carrying NM cables, which would be like 12 twos. And a lot of people use that as like a work practice, as like a trade practice. And there's nothing wrong with that. You know,
nope.
you can use that as a trade practice. And, you know, a lot of people, they get crazy on this ampacity adjustment thing. And they just think, oh, well, you have to adjust for this, or, you know, there's some of these code guys that for some reason their attic gets to be like 168 degrees or something, and then you have to correction for that. But if that's less than 10% of your overall run, then you don't need to apply that correction factor. So and a lot of people get confused on that, and they're like, yeah, well, these guys say you got to correct because, you know, it's floor to attic. Well, yeah, if it is, if it's a floor to attic, then yeah, you're going to have to do a temperature correction. So it's just one of those myths that I just wanted to kind of tackle and just kind of let some of the younger apprentices know out there that you can put as many conductors, you can put as many NM cables until the wood splits open if it's not getting sealed.
Sure.
So
And, I've had people say, well, what if they seal in the studs? Well, why would they seal in the studs? You want to seal at the top plate. So I
Yeah, and
never understood that comment.
yeah, and some of this stuff, like that's what we run into a lot of times is they're like, well, the inspector wants me to putty pack the single gang Carlon boxes. And I'm like, why? And if
Yeah.
you go look right on that Carlon box says it's 2-hour fire rated.
Mm-hmm.
And the reason they do that, and people are like, what, 2-hour fire rating in residential? And it's like, well, these are mostly for multifamily between like party walls. And you know me, I'm here in Colorado, they're a bunch of them stoners are gonna burn the house down, is what they're always worried about. But these inspectors are like, yeah, you got to putty pack those boxes, and I'm like, for what? And they're like, oh, well, there's holes in there. I was like, so what they're worried about is that membrane where it penetrates the drywall and
Mm-hmm.
and exchanging from one side to the other of the wall. So it's kind of interesting when you get into some of these myths. So that is a busted myth. That was just one. I don't even know why I even put that one in there. It was just a job that I was doing. So we joke around about this a lot. I put it on a few of the groups where this could actually be a code violation for your cable bending radius. And what I usually use as a rule of thumb is if it could bend around a golf ball, then it's about right. It's like 5 times the diameter of the cable. So this one was just some silly pictures. I've used it on some of my group covers and stuff for like, to show like the resi guys can do the same thing as some of the skilled pipe work guys.
Well, at least it looks nice.
Yeah, it's kind of a joke, but there's actually some code violations in there if it's not supported within 12 inches of the enclosure. And then if you don't use the right cable termination method, or there's a lot of things that like obviously there's some that look like they're tighter than what the 5 times the radius of the 5 times the diameter of the cable, so that could be a violation too.
Sure.
So this is where I'm just illustrating going through the stud. Now, a lot of times in that top plate, that could be sealed because that's where your draft stopping would go, or your fire break or whatnot. But in general, this just a regular non-rated wall. This is 100% code compliant.
Okay. Oh, that sounds like we got a good myth of the week taken care of.
Yes, sir. And so you guys out there, if you have any suggestions, like if there's something like your boss is telling you to do and you think it's a myth or whatever, shoot me a message, and I'll do the research and I'll cover it, and we'll get it in there. We'll get it in the myths. And NEC for Dummies, I have a list. This is actually myth number 64, and oh yeah, Felix, we have that term. It's from Thomas Dimitrovich, and Thomas actually says everything out of an Eaton cup tastes better. But yeah, we say anything that you do wrong is ungood. So,
Ungood.
Yeah.
Ungood.
Yeah.
Well, I was planning on this week doing the topic of the week, but that isn't going to happen this week. I actually have James Stockett Sr.
All right.
that is going to pop it off for us. We were hanging around the office. He goes, let's go eat. I said, well, it'll be after the podcast. He goes, oh yeah, he got that. He goes, what are you teaching? And I said, we're going to be doing grounding separator drive systems. I said, well, hell, since you're here, you want to do it? He goes, nice. Yeah, I'll do it. I said, okay, well, I'll be here if you have any questions.
Hey, how many takes are we going to have to do? Because, there's some of these guys, they have to go through, it takes some days to do a whole bunch of takes, and they have to redo it. So,
there won't be a take on this. It was funny because he asked me, he said, you got it, Illustrator? I said, no, I did it different this week. I try to switch it up. It'll just be the text go through. And he literally hasn't looked at anything. So when you're hearing this, it's straight off top of his head. I mean, he doesn't have to look at anything.
Everyone out there, you're in for a treat. This is Senior.
Yeah. Senior is in the house. Now, what I have here, I want to before we get him started, I want to give him a little pop here. This is he has a YouTube site. If you just go over and pop in James Gray Stalk Up, it'll take you to the James Gray Stalk Up Electrical Training Institute. He has a ton of videos over there, and if you want to see illustrations about everything he's going to talk about in this presentation, they're all over there. I mean, for sizing, step-by-step calculations, how to ground the system. It doesn't matter if we have uh, Delta systems, whatever, if it's a grounded system, ungrounded system, it's a high impedance grounded neutral system over at Separate Drive. All of those exceptions, notes, everything that's in there, it's in the design book, and it's fully laid out to cover everything he's going to talk about here.
Yeah,
So,
I really did like his thing on his one he did on the outlet. What is an outlet? That Hot Topics has been pretty cool. Real quick, James, just to answer one of the questions that we have. I've actually tackled that. How many conductors can you put under a staple before? And we've actually done it where we put 3 under there, and people were like, "Oh, you can't do that," you know. And actually, what we found was that the majority of all the staples can only fit uh,
mm-hmm.
2 wire conductors, and they're only listed. Now, the one that we did where we put 3 under it, we were just joking around. It actually didn't say what it was listed for, but if you go into the UL standard of what those staples are good for, it literally says 2 cables maximum. So we've checked that out before, but I will do that. I will run it as a myth.
Okay, yeah, we can do that. We've already got the next 2 weeks of myth already taken care of.
I
So,
know. It's getting full.
yeah. You know what's interesting is we're getting a lot of people that are messaging us, emailing us. What about this myth? What about this myth? And
Yeah.
even on the NEC for Dummies, it's getting sort of funny because we have a part there about myths that are there, and we keep adding to that. Just
Yeah.
all the comments everybody.
I'm gonna get some off NEC Live, and NEC Live. I've been real fortunate to be sharing their feed every week. They have a podcast on Wednesdays at 6 p.m. Eastern, and so if you guys are free on Wednesdays, we'll be sharing that on the NEC for Dummies, so you can watch any of them on there.
Now, I'm going to disconnect here my headphones. If y'all hear a little whistle, I'll let us know. I'll turn the volume up down to try to get rid of it because I didn't realize I needed a splitter so both of us would have it. And he's got hearing aids there. I don't know if it'll mess with them or not. So I'm going to move over and I'm going to let the man of the hour take his place and unplug this and let him tell us all about ground and separately derived.
All right, you're up. All right. I appreciate Snyder and James asking me to do this, but I hadn't had a chance, as he previously said, to review any of this. But I'd like to first start off with separately derived systems to define a separately derived system. And you users of the code, in Article 100, we can define a separately derived system. And basically, except for the equipment grounding scheme, those conductors, do not go from primary to secondary. It's just the equipment grounding that can be connected to the XO and the grounding bar and so forth from the supply side. Now, we'll be talking about 250.30 and some of these sections that you see listed in 250.30 on the screen. But in the informational note, we have to determine what is a separately derived system. And of course, you know yourself from your experience, if you have a transformer and you are going to have a generator instead, then it's how you treat the grounded conductor at the transfer switch. If you switch the grounded conductor, you have to ground the generator. If you don't switch the grounded conductor and you ground it to the utility ground as well as the service equipment ground, and it's solidly connected, then you don't ground the generator. But you install the generator by 250.35, and if it's 15 kV or less, you're going to go over to 702.12A and B. A, I think it's less than 15 kV, and if you go to B part, it's greater than 15 kV. A.
Hey,
So
can I ask a question really quick, sir?
Yeah, go ahead.
Why would you size the neutral conductor based off of 250? Because it doesn't really. I was just curious why we actually size the neutral for like that separately derived system, like why it's based off like the ground and the neutral. And it's saying grounding, but we size our neutral off that. Can you explain that a little bit?
Yeah, the reason that we used to do that is because you don't get an inrush when you switch.
Okay.
See, when you switch that neutral, you don't get any kind of inrush on it when you make the switch. And if you have a lot of sensitive electronic equipment, you don't get that surge to it through the neutral, especially on the Y system.
Gotcha. Okay.
And that's the main reason for it. Then the other reason, mainly that an engineer will do this, is because a 4-pole transfer switch is a hell of a lot more money than a 3-pole. And, these electricians out there and engineers know that. You're going to spend a hell of a lot more money if you have a 4-pole and you switch at neutral. Plus, you got to ground your generator. And then you have to come up, how you would identify the grounding scheme.
Right.
Because you're switching, see.
Gotcha. Okay, that makes sense.
But that's the main reasons that you would want to do that. If you don't want any inrush, coming over that neutral conductor. Gotcha. And then if you want a 3-pole, which is cheaper than a 4-pole.
Okay, gotcha.
All right. And then, of course, you're looking at your disconnecting means to the generator in 445.18 and 445.20. If you have a disconnect at the generator and it's within 50 foot of the building, then you do not need a disconnect at the building. Gotcha. If you do not have a disconnect at the generator, then you do need one at the building. And then you'd go to this 445.13 that you see in the informational note 2. And to be able to place that disconnect at the building instead of the generator, then you'd need to apply a calculation of 115% of the generator's output.
Gotcha.
But if you run, say, like 3 feeders, and you just size the conductors based upon the feeder, not the output of the generator, now you'd have to have a disconnect at the generator.
Hey, one stupid question, sir, that I just wanted to ask. This is kind of unrelated, but is that generator required by code to have an emergency shutoff switch?
It depends on the manufacturer, and you go back to 110.3B. And now, when you say emergency disconnect, what's that for? A dwelling or what?
Well, just in general, we did one for a fire station, and it had an emergency shutoff switch. Yeah. It was like basically called an EPO, and we put it in, but I just didn't know if that was required by code or if it was just something that maybe the manufacturer requested.
Well, it's usually if you have an emergency cutoff switch, it's usually by the manufacturer, and that's in 110.3B.
Gotcha. Okay.
Yeah, and when you look at 445.13. It's just telling you when you have to have a disconnect at the generator, or would you have a disconnect at the building? And then, it's that 50-foot rule if you have it at the generator.
And so with that 445.13, would that have to disconnect all ungrounded conductors?
Yes.
Okay.
Yes, for the feeder, yeah. Okay. Now, if you had 3 feeders going out, you'd have a disconnect for each feeder.
Right.
Yeah. So they usually set that up for that. And then some companies that, manufacture these generators, they require disconnect at the generator with overcurrent protection.
Right.
So you have to look and see if 110.3B will let you revise it in any way. Then you have to look to see if you have a a generator that falls under 702 C.12.
Gotcha.
And,
Which
that's an optional
702?
standby type generator.
Okay, that's emergencies, right?
Yeah. And then if you're
Okay.
classifying your generator, then we always go to an emergency generator, go to 700.2, and there it will tell you the loads that would be on that generator for it to be classified emergency. If you go to 701.2, then those are the loads that would be on the generator for it to be a legally optional standby generator, or legally required standby generator.
Gotcha.
So we used to take, sometimes we would take loads off of the 700.1 generator that dealt with egress, emergency, and all that, and have battery packs and those kind of systems put in. And
Right.
then we could fall under legally required standby, bring it on in 60 seconds, and have a 15-minute delay.
Okay.
Where if it's emergency, from your experience, it's 10 seconds that
Right.
you have to bring it on. And then
Right.
you get into NFPA 110 for maintenance, and it makes a big difference.
Right. And then the other thing I was gonna say was like, so you have your neutral and your ground bonded at the generator, and then that would make it not a separately derived system, right? And then if they were separated at the generator, then that would be a separately derived system, correct?
Now, see, you look at when you look at the generator and you ground the generator, then that's a separately derived system.
Okay.
If you
Okay.
don't ground
Okay,
it, it's
backwards.
not.
Okay, I got you.
And see,
All right.
that's what it's telling you. And when you review 250.30 informational note 1, so if you look at that informational note 1, then it says the whole key there is about that 1, 2, 3, 4 lines down where it talks about that grounded conductor, and you're switching it.
Gotcha.
Where it says
Okay.
switching action. Now, when you
Okay.
go down to information note 2, then you're 445.13, you're a separately derived system.
Okay, so it's kind of a stupid question, but so typically those informational notes are not enforceable, but could they be enforceable under this?
Well, no, all they're doing is giving you information of how they would consider a separately derived system.
Okay.
And if you read and say a transfer switch and review it, well, it's telling you that it can be a 3-pole or 4-pole. So that's just telling you how you would treat it to determine if the generator would be separately derived or not. So
Right.
they're just informational notes. They're not mandatory rules.
Oh, gotcha. Okay.
Yeah, that's
And
all
and
they are.
and
But they just,
that's basically off the style manual, right?
yeah, and it would just give you information to help you understand when that generator separately arrives and it's not, when you have to ground it, when you don't. And if you're connecting it in with a utility, then you have to go over to 705.12D and E to connect it. And you know what the rules are. You can't let it feed back into
Right.
the utility system.
Yeah, and I should say grounded conductor instead of neutral. That's kind of my bad.
Oh, that's all right. That's no problem with that, because if you do not have an overcurrent device out at the generator, it is a grounded conductor.
Right.
But if you have an overcurrent device out there, then you're going to treat it like an equipment ground. See, then you'd have the neutral.
Right. And then that's only used for a pathway to ground, correct?
That's right. If it's a neutral, you're picking up neutral current by 220.61 is how you'd size it. And
Right.
then the equipment ground would be sized upon the breaker
Right.
at the generator.
Gotcha.
But if you had just conductors coming off there with no overcurrent device, now you got to go to table 250.102, C as in car 1, and size it off the conductor. So if you had 4 alt conductors, for example, with no overcurrent device at the generator, then you'd go to your table 250.102C1.
Yep.
Around page 123.
Yes, sir.
And it would be a number 2.
And then in your design book, that'd be like the load side of your overcurrent device, right?
That's right.
Okay.
But that's code too. If you go 250.142 A and B.
Yeah, I was trying to pay attention in class for the stall cup design class.
But those are some of the things that you would kind of pick up, and so we know that a transformer is separately derived
Right.
if you're on the load side of the service, and you
Okay.
have a main to the primary, and then you tap off of the secondary with transformer secondary conductors, and that you tap it by 240.21c.
Tempor.
Yeah. So here we're talking about in 250.38. So you're talking about the a grounded system. So that means that your transformer is grounded, and if you ground it to transformer, you have to make sure you don't have a parallel path.
Tempor.
Yeah.
Based off 250.6, right?
Yeah, you would have that
Uh,
section that tells you that you can't have a parallel path.
objectionable current, correct?
Right. So you would have a metal conduit. You couldn't bond the grounded conductor or neutral conductor, in this case, at the service, not service equipment, but a panel board with an enclosure, in 408.36 deals with that. From your experience, we
Yes,
deal with
sir.
that.
Yes,
No,
sir. A lot of times, what we do is we either bond it, the neutral and the ground at the panel, or we ground it in the transformer. And
well, you can do either one. You just have to
right,
take the XO loose at the transformer if you ground it at the enclosure.
yeah, and a lot of times, what the transformers have is they have a factory installed bond jumper in there. So we'll just isolate it at the panel where it enters at the panel. So
You just be careful not to take the chassis ground loose.
yes, sir.
It's the XO that you don't want connected in, like you said.
Tempor.
Yep, you're right. And then that you could ground it right at your equipment if it's a panel board or whatever that you have, a switch, whatever you may have. Yeah,
It's
and if
got to
you
be one or
grounded
the
it,
other. Got to be one or the other. Can't be both.
yeah, and if you have metal conduit on the secondary side of that transformer, from the transformer, say, to your equipment, then if you had a neutral, it'd be isolated from the can.
Tempor.
Yeah, and then you
Gotcha.
put a grounded conductor in based upon the largest ungrounded conductor.
Well, I don't know if you know this, sir, but we actually did one of our myths where we piped. We had hard, rigid raceway to our transformer, so that was one of our myths. A lot of people say you can't do that.
Well, I don't get to watch everything you guys are doing, but I know y'all providing some good material out there for the people to review,
Well,
and
I
I think that's
appreciate that.
good.
I appreciate that a lot.
Now, when you look at the informational note, in 250.32, then what you're looking at there is where you feed from one building to another building,
Right.
or you feed from a substation to a building. And if
Right.
we wanted, for example, to put all of our service equipment in a substation, it's permitted to do so by code, then that's the feeder going to the building, isn't it?
Yes, sir.
So if you go over to 225.32 and look at the section 1, you could have all the mains you wanted under certain conditions at that building, couldn't you?
Yeah, as long as you don't do the 6 handle rule, correct?
No, you can exceed that.
Okay.
See, if you look at 250.33a, you're correct.
Okay.
Absolutely. 6. But if you look at the exception 1 to 225.32 and go to 250.32d as in dog, then you could have all the mains you wanted, because your main switch of 6 or less is at the substation.
Oh,
But you got to
gotcha.
be an industrial building and meet all the rules, Snyder, to do that.
Tempor, sir.
That
Um,
you can kind of look that up, and I think you agree.
yeah.
I hope you will.
Yeah. No, it's hard to argue with you, sir. One thing I wanted to ask too is like, so there's a code basically that if you have, like, let's just say you have a feeder go out to like a detached garage or something, then you have to bond that. Is that like an IEEE standard or something that's not governed by 70 or?
No, it's governed by 70. If you look at 250.32B, exception 2, it says in there that if you run no more than one branch circuit out there, as defined in Article 100, then you'd bind there, but you wouldn't have to drive a driven rod or ground out there to, But if you run more than one branch circuit out there, then 250.32B, along with this exception 2, would say you'd have to set a panel board then and ground to either to an electrode system present, or you would have to drive a rod.
And everyone knows I'm no hack. I drive like 4 ground rods. I do like code times 4. So just so you know, I exceed the code at all times.
Yeah, and I think you and James went over that well. That if you look at the IEEE Green Book for power system grounding, if you had an 8-foot rod, you move over 16 foot.
I like that. Yeah, I learned
because those are your cylinders. See, 8 foot around. But if you had a 10-foot rod, it's 10 foot. So that's why, as electricians, and I think some of you electricians out there, may have done this. Maybe you shouldn't, but if you hit a rock or an obstruction, sometimes electricians will cut it off.
Right.
And maybe you only have a 5-foot rod, so you only have 5-foot cylinders of earth surrounding that rod to reduce the resistance on that rod.
Yeah, I mean, to me, I don't think the ground rods really do as much. I mean, they're just, I don't know. I mean, to me, it's an important part of the system to brace the building, but I mean, it's in all actuality, like when you look at that, what it actually, the gradient of it, I mean, it's crazy. Like when you put 120 volts to that ground rod, then you look, I think it's like 12 inches away, it's like 80 volts.
Oh yeah. Yeah. And if you have computer systems, if you have 20 amps or more flowing on that neutral, they tell you ought to go in there and balance it out as close as you can, because some equipment, not like today, because our computers and systems are designed better. But back in the old days, boy, you would have trouble with that, and you'd have to try to balance it out. And that's what I used to like before the 75 code, and we changed the color coding.
Yeah, I think they were using like the super neutral, like they were doing the 200% neutral to kind of accommodate for that linear load.
You're right.
Not non-linear load.
You're right. Yeah, we used to double it many times. We did. Sometimes even on a feeder, we double it.
Nice.
Yeah, you're right about that. No doubt about it. And then if you get into the informational note, 250.142, deals with supply side grounding. You don't have an overcurrent device ahead of your conductors. 250.142B of that informational note, it's not listed there, would be the load side. And that means you have an overcurrent device ahead of your conductors and you're always load. So as electricians, we should always look at it as an overcurrent device ahead of your conductor, so there's not one. Right. Then we know if we have to use table 250.122 or table 250.102C1 based upon overcurrent protection, or there's not an overcurrent protection ahead of your conductors. You're coming right off of the windings of your power source. And then when we get into the exception now, that's an exception to the rule. And a lot of you folks know we had to take a lot of informational notes and make them exceptions, and had to take exceptions and put in full code text. Because an exception is something that you use occasionally in relationship to the main rule, in this case, which is 250.30A, isn't it? Grounded systems. Right. So in the exception, we're using high impedance grounding.
Okay.
So 250.36 is mainly, really 480-277. And right. 250.187 is 4160 and above. But right. Mainly,
Medium voltage.
Yeah, you got it, boss. And
a question for you. So what would solar fall under? Would it be a separately derived system? I mean, I know I could probably look up the substantiation or CMP6, But I was just curious if that is considered a separately derived system, or if it's as considered paralleled with the 250/66 with your service entrance.
No, they kind of, to me, straightened that out a little bit in the 2020 edition.
Okay.
Where they said that it's not considered as a service or a separately derived system. It's
Okay.
just a power source.
Okay.
It's the generator that you get into that could be a separately derived system, but I don't know anywhere in 690 that a PV system or anything like that. It's just a power source.
Oh, I said the bad word and said solar. I should have said photovoltaic. Thanks for the
Oh,
correction.
either way, I knew what you was talking about.
Yeah.
But basically, I thought they kind of straightened that out. We're used to a lot of your engineers and electricians would say that a generator would be a service if it was used by itself.
Right.
Remember that?
Yep.
You could only have 6 mains and you had to treat it like a service, and
But
they changed that.
That's not under normal operation either.
Yeah, they changed that. So
Right.
I can have a generator feeding a facility, and that's not a service.
Gotcha.
Yeah.
Yep.
And so they straightened a lot of that out, and engineers like that. IEEE, they kind of come up with that and had one of their engineers submit it.
Nice. Well, it's
So-
really awesome to have you on here and pick your brain a little bit. So hope I'm not interrupting your
Oh no,
topic
you're
there.
not bothering me at all.
All right.
No, you're not. I've taught for over 50 years, so I can switch gears pretty quick.
Yeah, well, I'm one of those problem students that you just like, hey man, you're making my lesson take too long. So.
I used to have a kid like that when I first started teaching. He'd come in and he'd say, Mr. Stalkup, why is the sun shining today and there's no clouds out there? I mean, he asked everything. He had to have an explanation on it. But 250.36, you guys would have the amount of current you wanted to flow by the resistance of the
Right.
high resistance. So, for example, if you had, say, 480 volts to ground, and you had a resistance of 20, you just divide that into that, wouldn't you?
Yes, sir.
And that's how you can kind of pick that up. But the exception just recognizes that. Now, one thing about 250.187 and medium voltage, like you just stated, medium voltage now is in the new Article 311, isn't it?
Yes, sir.
And then all your tables dealing with high voltage current for conductors and cables is in Article 311, isn't it?
High voltage live.
Yeah. But all of your components, switchgear, panel boards, and things like that you use is in Article 490, isn't it?
Yes, sir.
So if I wanted to size my conductors and select my overcurrent device, I'd go to 490.21a, wouldn't I?
Yep.
And get my arrangement. So I thought they did a pretty good job on that, I thought. But you can look at it to see what you think. But we want to remember that all of our requirements and rules for conductors is now in 311.
Okay.
But all your components is in Article 490.
Gotcha. Okay.
Now, and then, of course, now here we have a system bonding jumper, and that's different than the main bonding jumper, isn't it?
Yes, sir.
And for a long time, being an electrician and designing and installing, we had a problem with that in terminology because people was calling that a main bonding jumper.
Do you want to know what the terminology problem is today that they're having a problem with? And I know you're probably not all hip on this PC culture stuff, but you can't say MBJ anymore because it has BJ in it. So
Yeah,
I thought
yeah.
that was funny.
Yeah, you have to watch what you say today. I was out in LA doing a class, and we had always a big class for ECNM. We had about 250 people in there, and a lot of women.
Yeah.
And just talking, a guy asked a question about a motor enclosure, and I said, yeah, that peckerhead. And
I knew
they
you were
wrote
going.
me up, boy. They said, Mr. Stalkup's a nice man, but he sure used some sexual terms,
Well, Felix says we have to change our name of our show to the 311 show for high voltage.
Yeah, we just sometimes you just have to watch, some of those slang terms we used out in the field. But this system bonding jumper, if you if you go and review the definition, then it tells you exactly what it is. It has to be a separately derived system. That's the bottom line. And you size it just like you would the main bonding jumper from table 250.102C1 there on about page 123 of your code book. And then the exception 1 deals with 450.6 and deals with a single system bonding jumper, that could be used to bond and make connection to the grounded conductor.
Right.
And so, in other words, basically what that's telling me, you could ground the grounded conductor coming in, the equipment ground, and all neutrals to one bar, or you could have a separate bar for the neutrals and a separate bar for the equipment grounds and get 100% coverage of terminations.
Nice. I like that.
And then exception 2, that's going to deal now with that other building we was talking about. And this is where you was talking about too. If you drop down to the third line in exception 2, it says, you shall not establish a parallel path.
Oh, gotcha. Oh, there's where it is, right there.
That's where you pick it up. And then when you go to 250.32b, it says the earth is not a parallel path because you're going from building to building. So when you ground your electrode out there, you're going to have a certain amount of current trying to flow through the earth based upon resistance,
Well, and that's another thing. That's a good point because I always tell the guys too, you can't float your ground because the earth is not a good conductor for one, but you want to open that overcurrent device at whatever speed in that building.
Yeah, and if you look at the IEEE Green Book and the SOARS grounding book, as well as our grounding book, it's 5 ohms at a second building and 5 ohms at the main building.
Okay.
And if you don't have, as you just pointed, that equipment ground in there to return that fault current, you have 10 ohms into 120 volts, and you have about 12 to 15 amps flowing through there at the most.
Oh, wow. And that makes sense. That's pretty good. I always like to tell the guys easy math.
Yeah, that is a good thing for them to know. I finished a lawsuit in San Antonio where a young man got killed, had a young wife and two kids. And what they had is a 480, 277 volt system. And electricians have to watch this. He brought the 480 into a panel with no 277 volt neutral load.
Oh, wow.
So he didn't pull the neutral.
Oh, wow.
But we know 250.20b says you ground the transformer, you got to ground at the first disconnecting mains.
Okay.
So, states that. 250.21, all the items there, we have a choice. We can ground or not. But 250.22, we can't ground any of those systems like a isolation transformer in operating room, etc.
Right. And so what happened? So the ground got opened and it energized?
What happened in service and equipment, somebody mashed a hot conductor and it energized machine 2. Okay. He put his hand on machine 1 and machine 2 to lift himself up to free a jam.
Okay.
And the current flowed through his body, see?
Oh.
Back and killed him instantly. And that's the first time I've ever seen the city, engineer firm, and contractor, all of them paid 1/3 on that lawsuit.
Wow.
And they all missed it.
Just so everybody knows, May is Electrical Safety Month. So that's a good lesson to everyone out there. There's never a reason to work energized. There's the biggest thing that we're trying to do in electrical safety is ground everything. I can speak more about the importance of grounding and bonding everything.
And it's like you said with this boy, he wasn't really working anything hot. He was just lifting up to free a jam.
Yeah.
He wasn't getting into the components. It's just that hot conductor was mashed and it was bare, and it was, feeding a voltage on that dang enclosure, and that's what got him, and he had enough current feeding through him to kill him. See.
Well, and we had one out at the plant that I don't know if James told you about it. I think I might have told him about it. But one of the guys got lit up on 277, and it was a temporary install. And they removed the temporary for one of the machines or something. And when they removed the temporary, they removed the pigtail out of the J box. So then when that conductor got nicked, it energized that J box, and then he went to move the J box and got lit up on 277. So it's a good lesson.
And that's what that bonding jumper's for, is to prevent that kind of thing.
10-4. I agree.
Okay, and then, you folks out there, if you wanted to, looking at this 250.30 A1 exception 2, you might put there, we want to see also 250.32B, as in boy, and 225.32 and 250.32D. And you got that whipped. You don't need anything else. You're going to know you can establish a parallel path because all your information's there. So you basically treat that building like a sub panel. You wire that panel board like it's a sub. You isolate your neutral. You connect your equipment ground in, see? And that's how you would size that. Then it tells you that the ground is not considered a parallel path. So if you put those sections down, you're in good shape. You'll be able to look at that 250.32B, 225.32 exception 1, and then go over and look at your 225.32 and
Nice.
exception 1, and you have that pretty well whipped out there.
Nice.
Now, looking at this, say we're grounding our separately derived systems, and you're dealing with a grounded conductor.
Right, which
now,
everyone knows is the neutral. Sometimes.
Yeah, sometimes it is, and that's defined, by the way. If we go over Article 100, the grounded conductor could be a corner ground on a 480 volt delta, couldn't it?
Yeah. Oh, absolutely.
Yeah, and it could be a grounded conductor if you have one hot and neutral.
Yep.
It's not a neutral. It's used as neutral, but it's a grounded conductor. Why? Because it doesn't pull the unbalanced current of 220.61. And you can look that up in your book if you have it handy out there, page 79. And you can look that up. And it says if you have one hot, and I'm talking about a transformer feeding you one hot and a grounded conductor, that's not a neutral.
Right.
That's not a neutral. If you have a delta and you have an ungrounded hot conductor, grounded, that's a grounded conductor. Right. So a neutral is your XO, and it carries the unbalanced current, doesn't it?
Yes, sir. And just so everyone understands out there, and I was always confused on this, when you have, like, let's just say a 240 volt load and it's a balanced load coming from utility, you technically don't need that neutral point. We put it in there in case either one gets unbalanced. So if it's a balance, like if you have two hots and they're balanced loads, if you have 10 amps on I almost said A phase, but like, let's just say A leg, you have you have 10 amps on A leg and 10 amps on B leg, then your neutral point is at 0.
That's right.
So
you'd have to have 12 amps on one and 10 on the other, then you'd have 2 amps.
Yes, sir. That's why we put it in there.
And if you look at our design book and look at a 3-phase, the neutral don't pull hardly any current at all. It's the harmonics that eat you up.
Yep. Absolutely.
Yeah, that's right. And of course, now if you look at this, note this exception number 3. If you had a transformer that's 1,000 volt amps or less, and you're at, say, less than 50 volts or less than 30 volts, the number 14 can serve as your bonding jumper.
Right.
And but it's installed at the source, And why is that, by the way? Well, you folks out there, if you go to table 250.66 and review table 250.66, and I'm thinking that's around about page 117. It'll get you close. And you'd find number 8 is the smallest grounding electrode conductor. So that's why they come in and made this exception and said if you had number 14 or number 12 aluminum as your equipment ground, or number 12, you could use that equipment ground that's routed back to your service ground, and you could use it as a bonding jumper to bond the metal, that little enclosure. We have that little transformer that's class 2 or 3.
Right.
And you can go over to 725.121, 725.121, class 2 and class 3 circuits are defined.
Right.
And if you go to class 1, 725.41A, then you're going to have less than 30 volts at 1,000 volt amps or less, and that'd be power limited. Then you have unpower limited class 1 that we used to work with, and these, Snyder, 120,
Yes,
240, and 208, and then that damn 480.
Well, now they have in 725 136B, where basically you can combine class 1, class 2 circuits as long as the insulation is the same.
Yep.
So
That's
you can
good
combine
point.
You can combine it in the raceway, and you can combine it in the closure.
And then if you wanted to look at the output of class 2 and class 3, just a general output of them, you want to go over to your table 11A and 11B, and I'm thinking that's around page 706 or 707, somewhere in there, and you get the outputs, don't you?
Yes, sir.
Yeah, you get your outputs right there. So that's for that power limited class 1 circuit that you would get in 725.41, but 2 and 3 you'd have to go over at that table 11A and B for AC or DC to do that.
Right.
And then A, if you don't have any questions, we're installing at the source, and that's a system bonding jumper and that little transformer that will bond it all the way back to the service ground.
Yes,
and
sir.
You're still considered on supply side back at the source there. B.
Yeah, and we got a thing. One of our viewers, Felix Sandoval, says class 1, class 2, and class 3 circuits are exam killers. So he says that you got to know the class 1, class 2, class 3 circuits.
Now, if I want you to look this up.
Okay.
If you go to NFPA 70E and look under electrical hazard, it says that a class 2 circuit's not a hazard.
Okay.
But a class 3 and class 1 can be. You got to evaluate by 70E the output of a class 3 or 1 to see if it's a arc hazard or a shock hazard. But class 2, no. Class 2 would be like a little chime transformer that's usually in the closet right above.
Yeah.
They put it there, or they put it up in the attic if they have room.
Wow, I didn't know that. That's good info.
Oh, yeah. Yeah, class 2, and you can look it up. Just look in your 70E and look under your electrical hazard, and that's where you'll find it.
All right, yeah.
And now when we look at, we install, the system bonding jumper there at the transformer, and then if we don't install it there, we could install it at the disconnect. And then the exception talks about that you could have separately derived systems of multiple sources. And basically, it's telling you could use a common grounding electrode conductor and connect multiple sources and just tap to that. We don't have an illustration of her showing you that, but basically that's what it's saying.
So would the language be that it must be electrically continuous? So
yes.
It doesn't matter how you do it as long as it's electrically continuous?
Yeah, it'd be electrically continuous without it got damaged during construction or you had to move it for some reason. Then they would let you splice it with an irreversible lug.
Okay, gotcha.
We used to couldn't do that. We'd have to hide it,
Oh, okay.
I hope the inspector didn't find it, if the inspectors are listening.
Well,
But,
and they never found it because it always worked.
well, the guy, the chief inspector that hired me to be the chief plans examiner at the city, he came out one day and he called the office, and I just happened to answer the phone. And he said, I want you to go back out there and fix that damn grounding electrode conductor. He said, you spliced it. I said, one of our guys do that? He said, hell no, you did it. He said, they told me you did it.
Oh, no.
And I wondered how he found that. And after I went to work for him, I asked him one day, I said, Haltom, I said, how did you catch me? He said, well, the next time you splice a grounding electrode conductor that you cut too short, make sure it's not one of those vent bays that you put it in, because I shined my flashlight in there and saw it, because I knew he didn't get out of that house. I knew better than that. But he caught me on it, though. But now, under construction conditions, or you relocated, then you could splice it.
Right.
Now, looking at that, let's see, this is new here. Yeah. Now we're looking at 250.30A2 supply side bonding jumper, and that's just sized in accordance with the conductors. For example, if we had 4-aught conductors that were tapped from the secondary side of a transformer, we'd need a number 2 grounded conductor. Now, this is what we have to watch as electricians out in the field. You have to compare that grounded conductor with 220.61 on page 79. For example, if I had 4-aught conductors, visualize this in your mind, tapped from the secondary side of a transformer, we call those naturally transformer secondary conductors.
Right.
Based upon 4-aught 250.102C1, they're on page 123, approximately in your code book, would require number 2. But say you calculated a neutral load of 1-aught, then you'd have to raise the number 2 to 1-aught. And my first little old design job, I got in trouble. It was a welding shop, and it was an L shape. And in the office, they had just a few little old lights and everything. So I calculated my neutral, and it come out a number 4. But the grounded conductor came out to be 1-aught.
Oh, wow.
So I sized it number 4, and I should have been 1-aught, see?
Oh, wow.
And sure enough, the maintenance people got into a ground fault out there. And I was real fortunate. It was old Federal,
Right.
So nothing tripped at all, but the bus bar warped.
It was a welding shop, so they were welding with their panel.
It really, I'll tell you for one thing, I really felt funny when my boss took me out there, and I told him, I said, no, I'm going to tell you, I sized that, and in those days, it was 220-23. And I said, no, or 22, excuse me. I said, no, I sized that for neutral. And he said, I accept that. But did you size it for the grounded conductor for the fault current to travel over and use the larger 2? So to make this kind of short, that's what A1's telling you. See that 250.102C?
Right.
Yeah. And if you come down the supply side bonding jumper, 250.102C, and if you look at the exception, then you have your supply side bonders. Never has to be required to be between the enclosures and installations made in accordance with that A1 exception 2 we looked at, because we're using, a common grounding electrode conductor there in some cases, if that would be the case. Nice. But the thing you want to make sure of, and, the IEEE engineering group, if I remember correctly, come up with this. They said, why in the world are you sending us to size a main bonding jumper or a supply bonding jumper to table 250.66 that the title head is grounding electrode conductor?
Right.
We need another table that will address all of the terms of the conductors and bonding jumpers and supply side bonding jumpers that we have in the panel board. And
Right.
that's why they come up with table 250.102 C1. They're on about page 123. Notice in the title head, all of those components and elements are identified. Well, if you go to table 250.66 now, it's only addressing the sizing of the grounding electrode conductor.
Right.
But basically speaking, without getting too deep into this, table 250.102C is an overlay of table 250.66 and mainly there.
Hey,
Okay.
question for you. Do you remember what year that was?
What year
Yeah.
that they changed that?
Yeah.
Yeah, I think it was the 2014 code, I believe.
Okay, cool.
Yeah, I believe that's the year that change came about. Yeah.
All right.
Isn't that right,
cool.
James? 2014?
I think so.
Everyone, all my buddies will be giving me crap because they call me the archaeologist. I always try to like go back and learn about history and stuff.
Sometimes you have to.
Well, there's one thing that I've collected through the years, but I have every code book from 1897 up to 2020.
Oh wow!
Got them all in my library.
Well, you don't have the 1896. I have the first one ever.
Yeah, I got it.
I'm just joking. I don't know.
When I was doing a class in New Jersey for Princeton.
Uh-huh.
And this old man came up to me, and it was a 3-day class, and I think he was probably around 87 or something then. And on the last day, he came up and gave me a little package, and he said, "When you get aboard a plane going home, open this up." He said, "I think you're going to like this." He said, "You know, my boys, one's a doctor, one's a lawyer, and they care nothing about this electrical business."
Uh-huh.
I got aboard a plane, opened it up, and it was his great-grandfather's regular code book,
Wow.
1897.
Wow.
And from his notes, hell, they had as much trouble with that code as we're having with this one. Because he had all these notes. What about this? But it's interesting reading it. So I put it behind an airtight enclosure, and you can see it. But I have some copies of it. I think here, and if I'll have James send you a copy.
Oh, dude, that'd be awesome. Oh, that'd be really awesome.
It's funny to look at it and see some of those illustrations in there. You know, they're hand drawn about the equipment. It looks really funny from what we got today.
Wow, that'd be really neat. I'd be totally interested in that.
Okay, and looking at 250.30A3, we deal with the grounded conductor, and it shall not have to be any larger than the phase conductors, the ungrounded phase conductors. And then sizing for a raceway, the grounded conductor never has to be smaller in the raceway than 250.102C1, that table requires. So if we was in parallel, say, for example, and we had 3 alt in each conduit in parallel. We had 3 conduits and they's in parallel, L1, L2, and L3. Yeah. The neutral never have to be larger than 1 alt, as you see in B in the parallel there, you see.
Yes, sir.
But the equipment ground, now watch this. The equipment ground in 250.122F never has to be 1 alt or larger. It's just whatever the breaker would require if you had a breaker ahead of it.
That'd be the size of your largest ungrounded conductor, correct?
For the equipment ground?
Yes.
It would be, yeah, if you didn't have a overcurrent device ahead of it.
Well, that's on 250.122 is what you said, I thought.
You got it.
Okay.
Right on. And then you see this grounded conductor, they talk about that here. And if it's delta connected, you're just taking one of those grounded legs, and that is illustrated to you folks out there in 250.26, item number 4. I'll repeat that to you. 250.26, item number 4, I believe it is, talks about taking a delta system and taking one of the hot conductors and connecting it to ground. I had a young man call me, and they were having all kind of heck with this transformer because he was backfeeding it. Oh. And he come off of the 480 volt side And he called and said, there's nowhere to ground it. I don't have an XO or any ground. I said, well, you don't. You ground one of the phases, And he said, they told me you know what the hell you were talking about. He said, that thing will blow up if I touch it. I said, no, it's the same as grounding your neutral. You'll see
Right.
0 on it, see? But it tells you all that in 250.26, item number 4. And then it says, yeah, it's okay to impedance ground, which we already looked at, see?
Right.
And you go to that section and follow the requirements there if you're doing that. One thing about a high impedance ground, if one phase goes to ground, the system keeps operating, doesn't it?
Yes, sir.
Yeah. And then, we kind of look at that.
Well, I have a funny story about this transformer. The first time I ever hooked up a single phase transformer, and it says take H1 and H2 to 480, or it was H1 and H4 to 480, and then wire nut H2 and H3, and then it said take X1 and X4, and that's your 240 volt line voltage. And then it said take X2 and X3 and wire nut them and pigtail it and ground it, and that's your neutral.
Yeah.
And I was just like, I called up the transformer manufacturer. I'm like, man, this can't be right. And they're like, sir, refer to your local codes. And so I guess it would work the other way, but it was interesting, that.
Well, for you people watching, a transformer is stupid. If you keep all the current, say, flowing positive through the windings, it works fine. But if you add 2 windings positive and then connected one negative, in other words, current are flowing through 2 of them in this direction, but you connect one winding negative, it flows this way, and that's when it's going to trip. And the first transformer back, seems like 100 years ago now, that I hooked up, that's what I did. And of course, my journeyman, he was teaching me, and he said, James, this is what you did wrong. So it's the same way with a motor.
Right.
You have to keep the current flowing through the windings in the same direction. And as long as you do that, they're going to function properly. Just positive or negative flow is what you want.
Do you know what I did wrong on that one? I didn't want to ground it because I was scared. I thought, I didn't want to take X2 and X3 and bond them. I was like, nah, there's no way I take transformer terminals, take them to ground. There's no way. Do you know how I found out what was wrong?
How'd you do it?
None of the GFCIs would trip. They didn't have a ground reference.
Mm-hmm. Yeah, they and most of them on the branch circuit require their own.
Right.
Yeah. Well, that's good.
That's how I learned about it.
Everything works good long as you connect it point to point and nothing's wrong.
Yeah, I learned my lesson on that one.
Okay, now we'll pick up on 250.30A, grounded systems. And we're looking at the grounding electrode conductor in accordance with 250.30C. And notice you're going to table 250.66. And I may be wrong about this. My memory may be failing me, but I think it's on about page 117, somewhere in there, I think. And if you had 4 alt tapped off the secondary side of that transformer to a panel board main, 225 amps, then your table 250.66 would require your grounding electrode conductor to be number 2, wouldn't it? And then the exception, notice now, and you can take a separately derived system that is listed and is identified for use as service equipment, and then the grounding electrode conductor would still be sized the same way, but you'd be sizing it for a service and not a feeder because you wouldn't have a main ahead of it.
Yes, sir.
And then when you drop down to informational note number 1, 250.104D is your bonding requirements for the service. In many cases, is not a grounding electrode conductor. You got to make it one.
Okay.
If you go to 250, 52 C4, it deals with building steel, doesn't it? And it's
Yes,
an
sir.
electrode. But here it's not an electrode. So your bonding requirements of your metal water piping, if it's in the vicinity, it has to be bonded in, and you can ground your structural steel to that water pipe system if it's an electrode in accordance with 250.50A1 of your code.
Okay.
And then when
That's actually one that might even go into my miss. That's a good one there.
Mm-hmm.
yeah,
I like
yeah,
that one.
that's a good one. And exception 2 is 250.50, and all your electrodes are bonded together. So we usually go to the structural steel because the steel is bonded in. But 250.50 says you can't have the building steel floating or any electrode floating. They're all bonded together
Yeah.
to form a grounding electrode system.
Yep.
Yeah.
Effective ground fault.
And mainly that's it. And then 250.58 gets into your bonding rules of the electrodes together.
Right. Okay.
250.30A5 is your grounding electrode. And of course, if you mainly what I look at this section, if you're going to protect that grounding electrode conductor from physical damage, use non-metallic conduit. Then you don't have to bond it.
Well, I like that one a lot. The problem I ran into with this is now you have to support that PVC at shorter intervals.
Oh yeah,
And
you would have to support it, but it would protect. Say if you wanted to just use a Schedule 80 and protect it from physical damage. But yeah, you'd have to do that. And if you just used the number 6 and you wasn't afraid about it being damaged in any way, then you wouldn't have to support that like you would the conduit.
because there's certain code people out there that says it's a 1 inch rigid, it's not going anywhere. But I mean, and you don't need the choke on it. But if you go, there's an actual table in PVC. I think it's like 342. I think where it says if you're using PVC for your grounding electrode conductor, it needs to be supported at whatever. I think it's like every 3 foot.
Yeah,
Typically.
I always check with the authority having jurisdiction, but I always tried to go to the table of contents, look at my wiring method, and then I'd go to that section article that dealt with it, and it's always .30 now, and I would just support it accordingly there if it needed to be, and then I wouldn't have to worry, with the authority having jurisdiction on it.
Templar.
But if you're looking at your raceways and you want to know what is considered conduit, tubing, flex, just go to 300.17. And the information note has it all listed for you.
Gotcha. Okay.
Yeah, 300.17. And then you can go to the table of contents and get in the 300 series. And, of course, this. You can pick out the wiring method you want.
Dude, I love wiring methods, man.
Wiring methods. Well, wiring methods is abused so much.
Oh, yeah.
When you really think about it, they really are.
I bet you I could pull some wiring methods out of that 1897 edition. So I'm really excited to see that. That'd be awesome. Hey, question for
what
James.
You're going to find on service equipment, it says service equipment only needs working clearances that are practical.
Oh, there you go. I like it.
There was no 3 foot and all that business.
Practicable. We did a code change on that.
And boy, let me tell you something. If you go to New York and especially in New Orleans, they take full advantage of that in previous codes. In New Orleans, I've had to crawl through a crawl space into a panel room.
Hey, question real quick for Junior. David Englehart's asking when the next round of deathmatch. I guess David Englehart broke our system. He's got too many 300%, so he wants to see when.
Great. They'll be up Monday. We extended a week from the last one because I was busy doing some stuff, so they'll be up Monday.
All right, David. Well, I got a 80 on this last one, so I'm still
He's doing
hanging in there.
great.
I'm still hanging in there. David says he's in it to win it. Like I saw him the whole
So
time.
far, he is.
Yeah. So.
Okay. You ready? Did he answer your question?
Yes, sir. Go ahead. Sorry to
Okay.
interrupt.
So we'll-
Unless you could tell me why the sky is blue and why the sun's shining. No, I'm just kidding.
No clouds.
I know, right?
Now, picking up in this 250.30A5, notice they're sending you to 250.66. Make note of this. I'm not saying you guys hadn't already, you folks out there, but table 250.66 only sizes your grounding electrode conductor if you're connecting it to structural steel or a metal water pipe that's an electrode, see. 250.66A, you size the grounding electrode conductor to driven rod, number 6. 250.66B is a concrete encased electrode, number 4. And 250.66C is a ground ring, and it won't give you the number 2. You have to move over and look at 250.53 and look at that A3, and it'll give it to you. It's A3 or A4 right in there that you would look at. So keep that in mind that you only use that table by code now. If you're connected to a structural steel or to a metal water pipe that's an electrode or you're just bonding it in. Of course, that's interesting to go through 250.66. I mean, it really is if you really teach it like it should be taught, in my opinion. Right. But that's what this A5 is all about. Notice that A5 is a grounding electrode conductor for a separately derived system, 1, single. And then the exception number 1 deals with that system bonding jumper. And it says, it could be a conductor, a screw, a bar, or whatever. Where do you go to get that information, by the way? At that exception number 1, if you have your code book, let's put down 250.28. And 250.28 deals with that bonding jumper. What could be used? Like a screw has to have a color head, green. But in my day, it was either a larger head or a special configuration head, or it had nothing underneath it. It was just bonded right in, the ball right to the can. Yep. So, you can kind of keep that in mind with that exception number 1 there, just 250.28. Nice. Now, 250.30A5, again, if we're looking at that, it just says that a source of a separately derived system has to be listed and identified. Oh. So that's big.
Yeah.
If they come out on the job, the inspector, for example, if we have any listening, they go to 110.2 to approve your system.
Okay.
And it will send you over to identified. It'll send you over to approved. And approval is up to the authority having jurisdiction. See, defined. Then it sends you to identified, which goes through all that identified pertains to and what you'd have to be considered identified. And then the exception to identified, and you can look this up, it tells you how the inspector is going to make his inspection, his or her.
Wow.
It'll tell you there that you can, it'd be listed and labeled 110.3B, listed and labeled equipment, or it'll be equipment that's okayed by the inspector, or it'll be a NERDL put on the equipment by a testing lab with a state, county, or city that, who they approve for that, how many labs they approve for that. And basically, when you read through that exception number 2, that without reading it all to you, that's basically what it's saying, isn't it?
Hey, did you hear what one of the 2023 proposed changes are?
I haven't got into those yet. James is doing those with his understanding.
So 110.3B says listed, labeled, or identified.
Yeah, see, now, what they're saying, that the manufacturer can identify that equipment.
Okay.
Where'd they get that? From Europe.
Okay.
Europe, if you look at their code 6364, a manufacturer can identify their equipment or it can be listed and labeled by a laboratory.
But what if it's not identified by that manufacturer? It's identified by somebody else.
Well, if it's identified by somebody else, then that'd be up to the inspector,
Okay.
his or her,
Okay.
whether ordinance, if they were going to accept it or not, or they'd have to put a NERDL on it. City of Fort Worth will
Okay.
make you put a NERDL on it, a
Okay.
national recognized testing lab.
Hey, I got one for Junior. Felix Sandoval says that David Englehart, he is abusing the death match and conduit, and he's all out of conduit.
All right. Got it.
All right, Section 3. Now notice here, this ties back to that Exception 2 that we looked at for Class 1, Class 2, or Class 3 circuits operating at 1,000 volt amps or less, as you see there. And, that could be 120 volts. It could be 50 volts, 30 volts, whatever. And notice it can serve as a grounding electrode conductor too. So we bonded to the equipment ground, the enclosure, and then also that equipment ground can be routed back to the grounding electrode conductor at the service and serve to bond that little transformer. And we do that all the time with these little old transformers in, say, our residence for chimes, don't we?
Oh, yes, sir.
Yeah, same thing. Now we pick up A6, and that's the grounding grounding electrode conductor for multiple separately derived systems. And
ooh, that's a good one. I like
yeah,
that one.
and we used to do this. Inspectors would allow it, but notice, see where down, start at the bottom and count up 1, 2, 3, 4, 5 lines there. And you see what says common grounding electrode conductor?
Yep.
I can run a 3-aught and connect it into the grounding electrode system. And then I could have, say, 4 transformers, and I could bond and ground those to that common grounding electrode. And that's what that's allowing you to do right there.
Well, and me being like experienced like me, it never has to be larger than 3-aught.
That's right. And used to that, when they first come out with that, you had to take all these circular mill rating of transformers, and it had to be that size. It would be 350 or 400.
Yeah, with 12.5%.
Yeah, and they found out, hey, that's ridiculous when table 250.66 never requires it larger than 3-aught, so they did that. Yeah, that's a good point that you bring out there.
Nice.
Very good. Because they do that. So, for example, I could have a transformer, and I have 4-aught conductors. We'll keep that size coming off the secondary of that transformer to a 225 amp main and a panel board, and I'd have number 2 connected to that 3-aught, wouldn't I?
Yes, sir.
That's what that's saying. And then the exception number 1 says a system bonding jumper. It could be a wire, it could be a strap, it could be a bus bar, any of those things. Some people, I still get a lot of calls on this occasionally. How do you size a bus bar? Well, you'd go to 366.23A as an apple. And if you had a 1/2 inch by 4 inch bar, that'd be 1/2 times 4 times 1,000 for copper. And that's how many amps continuously you could put on that bar, couldn't you?
Wow, you know what? I think you hit on something that me and James kind of stumbled on. Me and Junior kind of stumbled on with the 1,000-foot run, huh, James?
Oh, yeah.
Yeah.
I learned that from him.
And if you took, if it was aluminum bus bar, it'd be 1/2 times 4 times 700 as outlined in your 366.23A. If some of you folks out there didn't know that, you can look at that and remember when you're dealing with a nipple, it's 24 inches or less in length.
Oh.
You get a 60% fill.
Yes, sir.
And you don't have any derating.
Okay.
But if it's over 24 inches long, you become a raceway Now you can only have 3 current carrying conductors in it without derating, and you get a 40% fill.
Yes,
If
sir.
it's a sleeve, it's open on both ends, and it's 300.10. Exception, I believe it's exception 1, I think it is. And
Yeah.
it says in there it's open on both ends and a short length is 10 foot.
Wow.
And then you can cut it in the lengths you wanted for a sleeve, see? And then if you
Wow.
go to 312.5C as in car, you can have a sleeve on a surface mounted panel board, terminate it with a connector, run it surface up above the suspended ceiling. It must be at least 18 inches long, and it has to be no greater length than 10 foot, and you can drop your cables down through that sleeve into your panel board. And what does it say? 10 feet's the max.
Well, it must be secured, right, for 312.5.
Oh yeah, absolutely, absolutely.
Yep.
You got to do that. All that's you have to be do that. Now, one other sleeve I'll mention to you guys out there and gals too. If you're out on a construction site, and say the general foreman come up to you and said, "I want you to protect this flexible cord that's run out here because this is going to be a main third way, a lot of traffic."
Right.
Go to 400.17. You write this down if you don't know where it is. 400.17. And there I can couple together rigid IMC, or I can glue together Schedule 80 up to 50-foot lengths.
Nice.
And pull my cable through it and have a great amount of protection there on a big construction site. And that's your sleeves.
Nice. I like it.
Yep, that's it. That's your sleeves.
Without the temperature correction factor and all that.
Oh, yeah. You always got to do that.
Yeah.
The code looks at everything as paradise.
Oh, yeah.
It looks at power factor 100%. It looks at routing your conductors through a temperature no more than 86 degrees Fahrenheit. It looks at no more than 3 current carrying conductors in the raceway until you get into your derates. Yeah, you're right.
Do you know what I asked one of my instructors when I was a 4th-year apprentice? This is really funny. I says, "Hey, can I upsize my conductors by 0.4% because if I guarantee that won't go above 80 degrees Fahrenheit?" And he's like, "Nope." So it's like everyone always talks about derating, but nobody ever talks about the other side of it.
No, and it's important. And a lot of people never look at that. They never figure in a wise system that a neutral can be current carrying. But if you go to 310.15E as in Ed, then it says if the neutral pulls over 50% current, the neutral's current carrying, isn't it? So
yes, sir.
So if you had 100 amps on L1, L2, and L3, if 51 amps is nonlinear harmonic current type loads, then your neutral's current carrying. So you have 4 current carrying conductors in a Y system, don't you?
Yes, sir.
A lot of people never derate for that.
Well, because it's 120 degrees separated, so.
And you get into those things. And the exception 3 is just basically, reviewing where you need a grounding electrode conductor, where you don't. Is it a separately arrived system with a main in it? Use the service equipment. You get into that into your exception 3, and then again you never have to have the equipment grounding the grounding electrode conductor larger than your table 250.66, and then of course 250.66 A, B, and C is when you're not connecting to building steel or water pipe.
Nice.
Go ahead, James. And this one now we're looking at 6A, and the common grounding electrode conductor should be one of the following: a conductor not smaller than 3/0, as Snyder pointed out, or 250 kc mil aluminum. A metal water pipe that complies with 250.68 C1, that it's either an electrode or you've made it electrode by bonding it in properly. The metal structural frame of the building, that could be used. And notice these are allowing you to terminate all your grounding electrodes to a metal water pipe that is an electrode within 5 foot where it enters the building. And most inspectors, now if we have any listening, they usually require, if you have buildings still by this rule now, they look at 5 foot there and you need to ground in within that 5 foot so they can see that the electrode system is complete with all the electrodes. And then when you get into B, then this is your tap conductor size that you would tap with, and you see that's table 250.66 based upon the ungrounded phase conductors. And then you have your exception that basically says that a common grounding electrode conductor never has to be larger than 250.66 A, B, or C for the type of electrode that is present. Now, they call that out again because people were requiring someone to try to ground a service to a driven rod using table 250.66, and hell, you can't even terminate it.
Yep. Oh, I've seen it. But we had a foreman that ran 3 out to a ground rod, and it's like, really? I always say like what Junior says. Okay, explain to me why you did that.
Yeah. Well, Junior's been around a long time too. He's getting to be an old man. Hell, he's nearly 60.
Yeah, he's an old man compared to me.
Yeah, and I guess I'm telling off on myself too when I say that. But now, looking at 250.30A6C, you get into your connections, and it goes through how connections can be made. You know, you could use exothermic welding. But now we used to use this C2, which was a different section. And if we were wanting to run, say, a conductor up through, say, the floors for a 10-story building, we would go by the IEEE Emerald book. And it says after it's about 250 kc mil, you know, you're not doing a lot to prevent unwanted noise getting to computers. You need to go to a 1/4 by 2 inch wide bus bar then.
Yeah, and we run into that in the gas and oil that you don't want noise. Yeah. You don't want noise in the control room, so we Equipotential bond it, and then we Equipotential bond the motors, and then we take that linear noise off of there, and then we just run what we call a triad, and then that triad has to be isolated from the other.
Yeah, and a lot of those instrumentation cables, you just bonded at one end.
Yep. Yeah, we call it the drain.
You get a lot of problems if you don't. But all this is telling you, and we'll move on, is this AC2 is telling you what could be used to accommodate your terminations necessary for installation. And, you know, you could use aluminum bus bar, copper bus bar. And again, if you had a 1/4 by 2 inch that you see in C2, for copper, just multiply that by 1,000. That tells you what it'll pull.
Yes, sir.
And if it's aluminum by 700, then just look at 366.23A. And then, of course, the one we use a lot for these connections is exothermic welding, which we used to call the CAD weld.
Yep, that's what it is. And we're still CAD welding today.
Oh, yeah.
I just do it with my cell phone now.
That's one good way.
Yeah, I'm just joking. I'm just saying I got the igniter all set.
I know what you're doing. But I guess that's all he wanted me to do.
Dude, I really appreciate all the listeners are all loving it. Like, dude, you're a true legend, sir. It's really awesome to have you on.
Well, if any of you out there want to see this in illustrations, just go to James Gray Stalkup on YouTube, and you can look at every one of these illustrations. But in closing, I'll just say this. When you deal with a separately derived system and you deal with a Article 450, that's just for the transformer, all your protections is simply for the transformer. If you look at 450.3, make note, 450.3, it'll refer you to Article 310 to select conductors, and it'll refer you to Article 240 for your protection for 1,000 volts or less systems or over 1,000 volts, and you have to protect those conductors, and all your percentages in your table 450.3A or B is for the transformer, not the conductors. Don't overlook 450.3. And again, Snyder, and you and James, I appreciate you having me on, and I hope I didn't bore the hell out of you guys out
Hey,
there.
is it too late for me to get a request from you for the James Gray Stall Cup YouTube channel?
Sure.
Conduit support. It's been a real hot topic, and I think you should cover it on conduit support, whether it's rigid, EMT, whatever, and interpretation on that.
Oh yeah, I'll go with that. I'll be happy to do it. I'll do a video on tomorrow for you guys and slap it on my channel. Okay, I'm gonna get out of here and let James have you now.
Awesome, dude. Thank you, sir. Awesome, dude. You're the man. You're the legend.
Well, thank you for saying that. I thank you.
Thank you, sir.
Well, that
was pretty good.
That was awesome. I like, if anyone wants to check out something awesome, another Stall Cup thing, go check out Senior doing 7 Steps to Motor Design. I think it was like one of our first shows.
Yeah, I think it was the second one, I think. But
that was awesome too.
I tell you, that is a lot of good knowledge right there. He just laid on us, and
yeah, that was awesome.
Most people have never heard about
really
the bus
awesome
bar
show you put together,
and how to calculate that bus bar to know what amperage it will carry. And he just has all that kind of knowledge, and that's why I like having him on every now and then. And it makes us go over a little bit from what we usually do the podcast, but he imparts so much knowledge. I mean, you just got to let him go, and I know people are still hanging on. So
yeah, I mean, I'm probably gonna be cheering because I'm watching the Avalanche game at the same time, but
no worries. All right, well, with that in mind, the next thing that we want to do is we want to take and look at the 2023 changes. And what we have is 5 new ones, and they're all definitions. There will be a few more definitions that will be in the next one. And we'll eventually, slowly but surely, start getting into Article 110 and then Article 200 and 210, 220, 230 and stuff.
Nice.
But they had the definition of commissioning, and they've come in and they've redone this. And what they did, they added in here, they got the process, procedures, and testing used to set up and verify the initial performance, operational controls, safety systems, and sequence of operation of electrical devices and equipment prior to it being placed in service. And the reason they did this is to make sure that we have and it complies with the requirements of the National Electrical Code. And they're in the substantiation, they tell you, really in the second sentence, they tell you this often includes special setup steps to adjust device and system settings with performance verification tests and interlock and safety operational performance. And then, of course, that is the validation of the sequence of operation. So really what it does, they clarified the definition a little bit more and encompass more terms and what the purpose is of what those terms are.
Yeah, I call it in blatant terms. If you go out to a plant, you're going to call it IO. You're going to be on the IO crew. And so IO means basically you're just turning stuff off and on. That's it.
Right.
If you're on IO crew.
But this was a definition that they come in and they've upgraded. And I thought it was important because they did all the different terms here for the verification and validation for the sequence of that operation.
Hey, did I tell you what my new challenge is, bro?
What's that?
I'm trying to say National Electric Code like one word. Like it's like a total challenge. Like all my friends will know I'm talking about. You have to say National Electric Code. It's so hard to do it all one word though.
Yeah,
But
they can just do National EC.
yeah, National Electric Code. All right.
All right. Now, the next thing they did, when I'm going through and I'm looking at doing these changes, I'm always looking and uh, I'm trying to figure out what is one of the most important changes as I'm doing this. And usually, corrosive equipment, I wouldn't have thought much about it, but after I started looking at it and looking at the notes and the substantiation, I was like, well, this is an important change because you'll see everything in yellow's new.
Right.
And what they've done here is tell you the air. We always had theirs, but now they tell you or enclosures without adequate ventilation, where electrical equipment is located and pool sanitation chemicals are stored, handled, or dispensed.
Right.
Okay. And then note one, it tells you about the swing pool chemical chlorine and tells you all about that. And then when you come in and you look at step two, they lay it out and you've got your standard there. So they're telling you what all of this deals with. And when you get over here and look at their substantiation for this, you'll see there's quite a bit of a substantiation here.
Yeah, and I mean you're not gonna be using Romex in that room.
Oh, no, no. Now,
Or NM cable, sorry.
the point they wanted to make here more than anything is that these areas or enclosures could be indoors or outdoors.
Right.
Okay. And then they tell you that the designation of area as corrosive has no specific distance associated with equipment and is based on what? The area that's lacking what? Ventilation.
Right.
That's basically what it gets into. And what they did, one of the items that was in there, they used to say similar locations. Well, they deleted it because they've done this in the code a lot lately. If it's vague and unenforceable, they remove the term.
Dude, nice. Yeah. And I think CMP1 was working on that, which like means a lot to me.
Yeah.
They did a lot of work on that.
I just thought that this was important of a definition because they're specifically now putting this together to let you know that these areas and enclosures could be indoors or outdoors. It's a clarification. And then they added a couple more stuff and made sure you understood that it dealt with adequate ventilation.
Kevin Muller, dang you. All right.
Now, this is a big change here because this is a new definition for countertop. And what they tell you here, this is a fixed or stationary service typically intended for food preparation and serving, personal elevation, or laundering, or a similar surface that presents a routine risk of spillage of larger quantities of liquids upon outlets mounted directly on the surface. Now,
which that's a change from work surface, right?
Yeah. What's going to happen is, and I sort of went over and looked, and I started looking at the receptacles, and when you go over and look at an Article 210 and you start looking at 210.52 and you start looking at your countertops, one of the new rules is that GFCI protection is going to be required for the whole countertop area. Well, now you got a definition here that's going to go in direct correlation with that if everything stays like it is. And they're telling you here, it doesn't matter what it is here. If it's food preparation and serving, personal elevations, or laundering, guess what? That's a countertop.
Yeah, and we're already doing that kind of right now, which I kind of like this one. I think it's a good change.
Yeah, I think it's a very important change. And like you were saying, work surface, it's telling you the difference between a countertop and a work surface.
Yeah.
That is what it is. And they tell you here, the main difference between the two types of service is primarily associated what? The amount of spillage that it may be exposed to.
Absolutely. I like it.
That's big change because the clarification is now there. I thought that
Yeah.
that was a very important change that needed to be discussed.
I
And then
agree.
another one they did, which is important, is Equipotential plane. They used to have a whole bunch of items there. Now they
Yeah.
just tell you this is conductive elements that are connected together to minimize voltage differences.
Yeah.
So
I
basically,
bet you they were getting some objectionable current in this, and that's why they decided to clarify it because people don't understand this one.
the one interesting part to this definition, and I'll read it in the committee statement in a minute, but they didn't use the word bonded together.
Yep.
Notice that they said connected.
Yep.
So when you go down and you look, they tell you in the very last sentence of that statement, they tell you the word connected was used instead of bonded to include what? Typical connections of rebar and wire mesh, in addition to specific bonding connections made by electrical workers.
Oh, I was gonna say bonding outlets, but I was wrong. You can't just say outlets for everything. All right, man, I got wrong on that one. It's the end of the bonding method.
Yeah, and they'll tell you this is where it's going to be usable in various applications throughout the NEC. So, I mean, you could be looking at swim pools, you could be looking at agriculture. I mean, there's a lot of things.
Yeah.
And
everyone knows that equipotential plane is the end of the bonding method.
yeah, and the great, yeah, yeah. Okay, I know where you're going with that. Now, the interesting,
it can't be common everywhere, you know.
No. Now, the great thing about this is we hadn't had to spend a lot of time on these 5 changes because they're pretty basic, but they are important changes to what's taking place in the 2023 NEC. And a lot of times I have to go through and look at some of the other changes that are taking place in the NEC, and then that'll make me have a decision if I'm going to decide that's going to be one of the most important changes as it pertains to definitions in Article 100.
Dude, I kind of like this one. That's actually pretty good change on this new one you're just doing right now, the ground fault detector interrupter, GFCI.
Yeah.
That's pretty cool.
Yeah, and this is for PV DC circuits, and they just want to make sure that you know a GFDI is completely different than it differs from what a GFCI is, and it specifically applies to what? A PV system.
Well, I was saying CMP6. I think it's CMP4 that does solar now, but I was wrong.
No worries. But those are the 5 changes this week. There was nothing major that we had to spend a lot of time discussing the changes, but the main thing about those 5 changes is they're applicable to what is taking place in other parts of the 2023 NEC.
Nice.
And that's why I covered those in the way I did. And but I will say this, it's going to get much more deeper. And
nice.
We're going to have to do some explaining on some of these changes. And it could take and cause our podcast to go an hour and a half too, like it is tonight. But
yeah, I mean, dude, like everyone that I asked, they said they didn't care because they're in. Like, everyone is like, dude, we're joining Code Ninjas. We want to know what the new things are, what they mean, and it could change. You know, folks, this is not set in stone.
No,
it could change. You know, the whole reason we're bringing this to you is because I like to be in the loop. I like to go, you know what? This is what this means. This is what this means. And if these changes are good, we can get behind them. We can, you know, get some people in the industry behind them. And, you know, I just want to thank James for actually both James Jr. and James Sr. for all they do for the electrical industry. It's so awesome. I mean, I don't do anything, you know, certain code people say I don't do anything for the industry, but that's fine. That's fine. I don't care. I'm not out there, you know, trying to be on code making panels. I would love to be on code making panels, but the whole thing is I don't have the time when I'm doing podcasts and everything else. So
I can tell you, I've been there, done that. Whoopie doo.
Yeah.
I'm on committees and everything else, and it's a lot of work.
Yeah,
And
and I'm willing to do it, for the industry or whatever, but I'm not gonna rub it in my viewer space or anything like, oh wow, you watch me because I'm a code making panel member. I think it's awesome. Congratulations, Ryan Jackson, code making panel 17. That's awesome, brother. I think it's freaking awesome that people are getting on there. I think Ryan Jackson will be great for code making
he'll
panel
do good.
17.
He'll do good.
He lines right up with that.
Yeah. And, it takes time and effort to belong to those type of things. And, I remember back when they actually had him chair one of the committees for hazardous location because it was all screwed up. And of course, I always go in as his alternate.
Is that code making panel 16?
16, I think it was back then.
Okay.
16, I think still 16.
Okay.
But I would have much rather been a code panel member instead of being his alternate, because everything that was coming in, guess who was the one that was collecting everything and sorting everything out for it to be voted on? That was me.
Yeah.
I tell you what, I learned a lot of stuff, dealing with that. And, I've been on task groups and everything for 70E, 70B, been there, done that, still doing 70E. And the EECA committee, we're on that. And of course, I'm an alternate, but I've been on there forever. And
I'm actually Ryan Jackson's third alternate. He hasn't agreed to it yet, but I'm his third alternate. In case he needs me, I'll be there to, like throw up a cool thing for appliances. Like some of this stuff is like no brainer. Like what they added to appliances on 210.8D was microwaves. Okay, throw a microwave on there. That's cool. You know what I mean? Like I'm not an objection to anything being on GFCI. Where I get mad is when they just make this one anomaly thing that just covers this one thing based on a death. What's that based off of? That's based off of poor wiring methods, and it has nothing to do with that it's not on GFCI. I mean, that's where I have a problem, and the thing is, like, okay, so you have one death. I mean, I'm not gonna tramp around one death. That is horrible that one child died from this accident. But what's more alarming to me is that it was a 20-foot long piece of seal tight. There was no equipment ground. They were using the seal tight as equipment ground. The seal tight was not supported correctly per code. Got pushed underneath the AC unit. It was inspected by an inspector. It was a contractor that did the work recently. And, I mean, there's number 7. It's stupid to say that is the reason for having AC units on GFCI protection.
Yeah, and I'll tell you another thing that upsets me a little bit. They came in and they're trying to justify. And, I'm not going to say any names or anything, but they, say an outlet is at the end of the wiring method. And you say, well, if that's true, I guess a transformer and everything else is. And then they come in and go, oh, it's just common sense. A transformer's not. Well, if you're going to make a blanket statement, it applies to everything. You just can't. You can't do that.
So transformer is like a separately derived system, so it's not a branch circuit. So yeah, I see where you're going with that they have the branch circuit thing going, but it's gonna be tricky. Everyone, this is the most electrifying show on social media right now, and we're not trying to be controversial. We're trying to be real with what we deal with every day.
That's right.
And do I think that AC units need GFCI protection? That's class A protected. That's the whole thing. Because if you guys go into the informational notes, if you're sitting there saying Willie Jackerson is a liar, he probably is. He said he pulled like 2,000 feet of 3-aught yesterday, But Willie Snyder, I'm not going to do you wrong, man. I'm going to go give you the information. We're going to check it out. and we're going to go in and we're going to tell you like right where you find it. And to me personally, I don't think that GFCI protection, Class A protection for AC units is saving people's lives.
Well, it's not only that, it's not incompatible. And
Yeah.
I will say this to anybody that's listening to this podcast. I'm always trying to do posts and stuff on the different Facebook groups and all my other social media. And I did one yesterday, late last night or early this morning.
Dude, it was awesome. I really liked it. I was blown away. I read it.
If you go look at it, it's 2023 NEC 210.8F, and I correlate it with 210.8D, and I show the new text exactly how it is. I go through both substantiations from first revision, second revision for 2023. Then I put the TIA up, and then I give full opinions and statements of what I think, and I break it all down. I think anybody that's interested, you should go look at that because it has a lot of information. It's in a video-like format. It goes through all of it. You're going to have to stop the video in some spots read because there is a lot of information in there. And I explain about the compatibility issues and everything that's there. And, one of the things that I just do not agree with, but they did a TIA and talked about the mini split and all that. And then all of a sudden, they're not even mentioning that in the 2023, not in the first or even second revision.
Yeah. And I think they kind of stumbled onto something, which I don't think is a bad thing, but I didn't know about the putting 10 milliamps of current, flowing 10 milliamps of current on the equipment grounding conductor. But I think CMP2 kind of stumbled onto this, which it is a bad thing. It is definitely ungood, Felix.
Mm-hmm.
But I'm not disagreeing with that. But what I'm disagreeing with is that saying that if these devices are like being uncompatible because of this flowing voltage on the equipment ground, that's one thing. But what we're having usability issues with devices with equipment that doesn't have this. So I think it's kind of being used as a scapegoat kind of thing where they're like, oh, it's because of these mini split units. Well, that's not the only problem.
Well, I'll take it a step further than that. They recognize certain AC units, and then in this 2023, they don't even recognize any type of AC. They're saying all AC units. Oh, really? So before it was a problem with certain AC units, now it's just everything. I mean, make up your mind which one it's going to be, and that's why I
stand behind Brian Rock, you're badass, Thomas Dimitrovich. Like, you guys are awesome, and you guys taught me a ton of stuff. Like, they're both on CMP2, and it's awesome because I'm backing that up, but at the same time, I'm disagreeing with them calling that an outdoor outlet.
I don't think it's an outlet. I think it's a termination. I've said that from the start.
Yeah, I agree with you. I mean, I could not wait to do that podcast we did in August. And, the whole thing was, it was like, I had to do it because I was like, I need to know what the truth is on this GFCI protection thing.
What was funny about that? I didn't even know what was going on. You just were asking me. I said, oh, no, if you go over here like this, all of a sudden I got jumped on left and right. Saying, I'm done.
My mistake, sir. I apologize. But the whole thing was, I was in with the clan back then. Now I'm kicked out. I'm not in with the clan. So you're good. You're safe now. But the whole thing was, it's like I was like being like the investigative reporter. I just wanted to go out there, get the truth, and go, all right, this is what the truth is on this. And you know what? I appreciate you and your dad's honesty. Like your dad was honest about every single thing he knows tonight. And that's going to show because this podcast is going to be 10 years from now. And everyone's going to be like, wow, Senior is just a wealth of knowledge. And I will ask for my 1897 code book in the mail. No, I'm just kidding. I'm totally joking. But
I will
I mean,
say,
to me, that'd be awesome. To me, like nobody's ever offered me an 1897 code book in the mail before.
he's good, dude. And I'll tell people, if you want to know, go listen on. We put up his YouTube site. Go to that YouTube site and go over to Hot Topics and listen to him explain what's an outlet. That is fantastic how he explains that. All right, Bill. Now you're gonna have to quit watching the game because you got to do your tool of the week. So when you wrap this up.
Yes, sir. We're getting close. So just letting you guys know, we have a tool page, a tool group on Facebook called the Electricians Only Tool Review, and every week we come to you live with whatever tool we think of that we think would be good, make your life easier. This week we're doing the Bosch GPL3 laser. And this thing, it has a three-position thing. It's pretty good. I mean, you're never going to need more than this. A lot of my apprentices will verify that we use this. You do not want to have what they call drunk snake conduit. So you don't want your conduit to look like a drunk snake going down the hallway. What you want to do is you want to establish a nice straight line right down the hallway. Then once you have that straight line, then you can measure out the next conduit. I guarantee this was a really good tool for me. And I'm not going to try to pick sides on, which laser's better. I've heard that there's green ones that have better visibility in daylight, stuff like that. And there's a lot of really cool lasers out there, but this is the one that's my go-to. It is a good, affordable price. It shoots a nice laser. Like, I think I was going probably 300-400 feet pretty accurately. And we were shooting straight. Like, if you see the axis coming down that way, that would be the part we were shooting straight. But then if you want to go and just measure off the wall and then shoot straight up, it would shoot straight up too. But you have to make sure this actually has an auto level in it. So when you set it flat on the ground, it'll have an auto level. But if you set it on like a rock or something, it might be off by a little bit because it's auto level, but it's not that auto level. You have to make sure it has a clean surface. But overall, I give that a pretty good rating. The Bosch 3 laser, I give it a good rating.
3GL or whatever it's called.
Yeah. So
you
could swing that thing out, like you see that bottom thing.
Mm-hmm.
You could swing it out, and then you could just bolt it to a 3/8 all thread, and then you could just shoot it right down your line. Yeah. That's what we were doing. We're just drilling it right into concrete and then bolting it up to 3/8 all thread, then shooting it all the way down as far as we could. And then what we do is we just shoot it down that way, and then we just move our anchor point, our 3/8 anchor point, and then we just bolt it up to that and then just shoot it down more. And everything came out perfect. The owner showed up, walked all our runs, and they're probably 500-foot runs both directions, and they were tits. Awesome. And I like tits.
Well, I will tell you, for just my experience with lasers, when I'm teaching, I used to use red, and then I started using green, and I can tell you that green shows up better. I can guarantee it.
Well, and to Felix's thing, what I'll comment to Felix, what's nice about that is you could set the bottom laser, the bottom part, on your mark, and then your top one's going to hit. And that's what I like. And then if you have your other way, if you measure off the wall, so that three vector thing, it works out so fast and so easy. So you just measure up that wall, boom, and then you just measure up there, and then boom. And then sometimes what I'll do is I'll go shoot it to like a conduit and then measure what that is and then put a mark, and then I'll go all the way down like how far the laser will reach, like 200 foot, then measure out the wall, put another mark, and then shoot it up, hit a mark on the ceiling, and then I'll just go and just cross-sect those or intersect those lines. And I mean, it works out perfect because even if it's a little bit off, like a half inch off over that distance, you won't see it.
Right.
And that's what I really like using a laser. And the Bosch, a lot of my friends used to joke around about the Bosch being botched, but it's a really good tool, and I stand behind it.
Awesome. All right. Was there any other questions from anybody? We're about to wrap this show up. I'm gonna go eat. I'm hungry.
Go Avalanche!
I
1-0, baby.
I see you over there looking.
I've been watching it.
Trouble paying attention tonight.
I've been watching the game the whole time, but I really appreciate Senior coming on. Like, definitely awesome, kind words from Senior, and I respect him tremendously, and he has taught me a lot. Like, all he has to do is open his mouth, and I learn because he is just a wealth of knowledge. And I even noticed all the viewers on here have been loving it, and that's awesome. This is a true live show. There is nothing scripted here. This is all 100% knowledge of electrical, and we're so glad to bring this to you guys.
Sure are. And other than that, till next week, I'm out of here, and I'm gonna go. I don't know what we're eating, but he's buying.
High voltage live.
You
You snooze, you lose. No,
That's
just
right.
kidding. You will be able to watch the rerun of this.
Sure thing.
So
And
somebody just said they missed it, but you didn't miss it. You
didn't miss it. Go to Vote Online Academy on YouTube. Everything's over there. All previous episodes. We keep everything. We don't delete anything. What we tell you is what we believe in.
Join the death match.
Yep. All right. Everybody have a good week. We'll see y'all next week.
All right. Peace.